Welcome to Unusual GCSE Questions. And today's question is from November 2024's paper 2, Edexcel Higher, and it's question 7, and it's a question about isosceles triangles with some algebra. We're going to put that on the screen now for you to look at, and then we'll talk about how to do it. Here we go. Right.
Okay. So, do you want me to start? Don't mind.
Yeah, start.
Okay, so in the question, it tells you that we have a triangle ABC. It doesn't actually tell us that it's an isosceles triangle, but it tells us that AC equals BC, so it's clear that it is isosceles. It also gives you the perimeter of 72 centimetres, and the question asks, what is the area of the triangle? So it's clear to see that because each side is given as an expression, we're going to have to find out x first in order to solve the question. So.
Right. Yeah, so this is not a particularly difficult question. It's just a little bit unusual. It's question 7 on the paper. So if question 7 looks difficult, one thing you've got to remember to begin with is it's not. It's just an illusion that they've created by sticking algebra inside something. One of the basic ideas that you should always have is try and find two things that are equal, put them equal to each other, see if you get an equation that you can solve. So
it literally tells you it here as well.
Yeah.
AC equals BC. So we've got 2x plus 11 is equal to 4x minus 4. And then we just need to get all the x's on one side, all the other numbers on the other side. You can see that here we've got 4x, which is the bigger x term, so we'll move the x's to this side. So I take 2x from both sides, I'll have 2x here minus 4, and then here I want to move this negative 4, so I'm going to add 4 to both sides, so that's going to give me 15. So 2x equals 15, so divide both sides by 2, so x equals, you can either write 15 over 2 or 7.5. I prefer a fraction, but it's your choice.
Well, I'm going to say I prefer 7.5. Because obviously what we've got to do with this now is we've got to put x back into here and see what these side lengths actually are. So we're moving from the realms of not knowing what these are to knowing what they are. So 7.5, 2 times 7.5, that's 15 plus 11.
That's so interesting that you find that easier, because 15 over 2 times 2 is 15. Anyway, go on, sorry.
Well, I'm not saying I find that difficult, I'm just...
I'm just interested in how you think. Go on.
Well, 15 plus 11, that's 26, so I'm just going to say 26. 4 7.5, that's 30, isn't it? 30 minus 4, that's 26. Well, that's a surprise, isn't it? We should have known that. But you know what? That's a good check, isn't it? That's a good way of checking to see
that x is correct.
We didn't mess it up.
Yeah.
And now we've got 15 plus 5 is 20. So now we're kind of at the halfway point. Now we've got to work out the area of a triangle. One thing that's interesting to spot at this point is that this bit of information here, so far, we haven't needed it.
Because we found x, you can just plug it in.
I mean, whether we're going to need it, who knows, we'll find out. But what we've got to do now is find the area of the triangle.
So area of a triangle equals a half base times height.
But you may notice by looking at the triangle that we don't know what the height is. The height is this bit, obviously. So how could we find this? Well, if we've got a right angle triangle, what are we going to use?
Pythagoras theorem.
Pythagoras theorem. Right.
So cheesy.
Yeah. I like that. I'll do that again. So we've got 26.
This is your hypotenuse.
And half of the base is 10. Now, if you clever look, you can spot 10 is just the double of 5, isn't it? And 26 is double of 13, and you all know, don't you, that 5, 12, 13 makes a right angle triangle. Do you know that?
Yeah.
So
It is, however, paper 2 as well, so if you want to use
Yeah,
the formula, you're
just-
more than welcome to.
you don't have to do it this way.
Yeah.
This is just if you want to do it in a fun kind of way. So this is the enlargement of a 5, 12, 13 right angle triangle. It's worth learning 3, 4, 5 and 5, 12, 13 as being right angle triangles that have neat integer whole number sides, because they're so like neat, they get used a lot. So like just they've been used here, and it can just save you a few seconds or just increase the fun slightly. So anyway, that's 24.
So now we can just plug it into here. So we've got a half times the base, which was 20, and then the height is 24. So a half times 20 is 10, and then 10 times 24 is 240. So we have 240, and the units are centimetres squared because it's an area.
So we didn't need that after all, that was kind of irrelevant. But I suppose it is helping us to check that we've got it right. We can see, we can use it for that. But
Yeah.
anyway,
That's it.
any other hard questions or unusual questions you want us to look at? Let us know what they are and we'll do that.